Does the presenter view work here? Or why is it always like switching back and see like I'm not doing anything? So, do I need to do anything? Should we start? Okay. So we only have 20 minutes, I guess. Yeah. So all right, cool. Thanks everyone for coming to the Wars workshop. So my name is Z. I work closely with the Wars engineering team. So today I'm going to show you how to get started on Wars, the next generation decentralized storage system. And the agenda is just going to be me kind of peeling through the onion, going from the easiest way to interact with Walrus to more and more complicated things, all the way to an application built on Walrus, which is Walrus sites. So what is Walrus? Walrus is a decentralized BFT tolerant storage solution. It uses SUI as a orchestration layer. It has deep integration with SUI move and SUI object system, but that's not really required for you to use it. You can use it with HTTP API, with pretty much any programming language that you can come up with. So being a decentralized store system, it can theoretically be also used as a data availability layer solution that supports certificate of availability or proof of inconsistency and things that you hear with the L2 EVM world. So as a developer, you mainly have two options to interact with Walrus. The first is through publisher, which uploads your file, and a aggregator, which reads the file that you uploaded. You can interact with them just with the HTTP interface or with the browser if you're just reading it. Currently on testnet, those services are pretty much free. They're basically a indirection layer that allows you to interact with Walrus without dealing with any kind of the key management or wallet, anything like that. You can just directly use it, and I'll show you how. So in a more production-ready environment, you're probably expected to pay a small fee to make use of these publisher and aggregators as services. And if you really want fast reads, they can also provide you some kind of CDN solution there. And the next solution, a way to use it is to use the Walrus CLI, which I'll cover afterwards. But I'll just demonstrate quickly how to use the Walrus HTTP way of doing things, right? So, so first thing is we basically set the actual aggregator environment variables here. So I'm just using my good old terminal here, setting the variable aggregator and publisher. So the way to use it, as you see here, I have an image here, right? I just call curl commands, and with this URL, I will be able to just upload a particular image there. So it has already been updated, already certified it says that. So there's this blob ID here that's important, and that's what we're going to be using to actually retrieve this particular image here. To retrieve it, it's also pretty easy. Curl aggregator. I'm going to replace this particular blob ID here. So this is just a URL, right? So any language can do this. So I'm downloading this particular file here, and I can show you what it actually looks like if I can actually. Well, anyways, what? I think I'm having some trouble with just the overall way of doing multiple screens here. So, yeah, I can show you that, guys. So. Right, so this one's here. So that's pretty recent. And then if you look at the Hackerman. Did I spell it wrong? Yeah. So this one is, 3 days ago, right? So now this is the way to just use it with regular old HTTP API. So I'm going back, show you guys how this thing works. Yes, you can do that as well. I can show you that if I can. Actually, this is just gonna download it because it's seeing that as an octet stream. So, but you can play around with it more after this. I can get this back. All right, cool. All right, cool. So, just did the demo. You can probably go find how to use it in detail with this URL here. You can also visit our booth. We can give you all the some of the cards, NFC cards, with all the resources there. So, obviously, there are some use cases when you want to dig deeper, when you have more interaction with the actual client there, with all your wallet and all the private keys related things. So this is where you kind of use the Walrus CLI. So it allows you to be able to directly talk to the storage nodes with a SUI address and some of the wall tokens there to pay and rent spaces on the decentralized storage network. So the process to set this up is a little bit more involved, but because it needs to be able to talk to the Walrus contract deployed on SUI. So we need to install SUI binary, the Walrus binary, and config there. These are pretty self-explanatory once you follow the instructions. So you can kind of do that afterwards and ask us questions if you have any questions when it comes to installing those things. So I'm going to just show you how to do pretty much the exact same thing, but on CLI here. So if I can do that. So for the CLI thing, so this is basically, what's happening here? Okay, so this is the CLI. I basically type an info there just to get some basic information regarding the Walrus network. Epoch here means the day you rent the space at. So right now it's basically 1 epoch equals to 1 day. So when you specify the amount of time you want to store a particular blob, you can kind of use that as a guidance there. So what we do here is to just do walrus store. So here you have a bunch of those CLI options here. The most simple one is to do the same thing, storing the same thing, right? In a bit, it's going to give us some response there. Yep, so the blob ID, if you pay attention, it's the same ID as before, right? Ends with EMUQ here. Also ends with EMUQ. So it says already certified. And I'm going to now retrieve this. It's a pretty simple thing as well. So walrus read. And then you can just copy this. Because it's deterministic. It calculates the file with the erasure coding and then hashes it. Right. It knows it's the same file, so it doesn't. You don't have to upload it again. Right.
What if you upload the same file from different device?
What if you upload the file from a different device? Yes, it's going to be the same. If the underlying binary encoding is the same, then it's the same. It's more complicated than that. It's erasure coding. So, any other questions?
By default, how many epochs does it set when you use the CLI? Because you can pass an option, but
Yeah. You can pass the epoch option here. By default, it's one epoch.
By default, you're storing for 1 day.
Correct, but you can always set it to be more.
Can you set like unlimited, and or like you have to like say?
I think if you put it to like 99,000, the system right now might break, but I don't think there's a realistic usage for that. Yes, you could if you have enough wall token to pay for that storage, right?
Sorry. Do you prepay for that, or?
Yeah, you would prepay for that. You would prepay, but there's also the option to delete it, which basically frees up some of your pre-deposited token, right? I'm not gonna go through delete here, but it's a possible to manage. It's a way to manage your resources, not to preserve privacy, right? Because once you upload it, it's public. Everyone can see what it is, right?
So for the purpose of the hackathon,
So the question is, so for the purpose of the hackathon, should the epoch be set to 100 days? Yes, probably. 100 is a pretty good estimate.
and so what are like the maximum size of files, and what is the charge? Like, what do you charge?
Okay. The maximum size of the file on testnet right now is 13 gigabyte per blob, and the cost there, I would say, for 100 epoch, you can faucet the token there, right? So it's paid by wall token. If you're storing one just image, we're talking about maybe like 0.01 wall, which is very cheap. So the target price for mainnet is 50 cents per gigabyte per year. Yes? No? Makes sense?
Very cheap. Yes.
Okay. Are we good on time? I think we still have some time. All right, cool. 5 minutes. I can show you guys some other cool things here.
So you're not on mainnet yet.
We're not on mainnet yet. It's on testnet.
What is the maximum we can use now for testnet storage?
Sorry, can you repeat the question?
What is the allowance for testnet storage?
What's the allowance for testnet storage? You can upload anything you want, yes, as long as it fits within that 13 gigabyte per file / blob limit. Yeah, I mean, you can faucet those tokens on testnet, right? So there is a rate limit in terms of how much you can faucet. So that's your limiting factor there.
And it stores something somewhere. It's actually a working testnet.
Yes, it's a working testnet with different partners operating these actual storage nodes. Okay, cool. I'm going to show you guys quickly one more thing before we... So Walrus CLI, just showing that. Pretty simple to use. Walrus store, Walrus read, right? Just go to docs.walrus.site. You'll find all the information there. There's also a JSON mode that allows you to interact with it more programmatically. So if you have like a programming language that can parse JSON pretty easily, then you can probably just use this and do this thing with more complicated things, right? You can delete object, just mentioned there, to reclaim space. How it works, I'm not going to go over this. This has been gone over in the video that I posted for ETHGlobal. So feel free to go there, and it has all the explanation on how exactly it works. All the things there. So Walrus sites. This is something that's more interesting there, right? So this is basically an application built on Walrus that basically allow you to store all of your website's content, static content, on Walrus and retrieve it back in almost as fast as you retrieve like a normal website. So this is stored through a portal, and what we mean by portal is that it's a service worker, usually on your browser, that retrieves those information from the Walrus aggregator. So there is also a way to do this thing with a server-based portal. It's basically have the same blob ID there. So every time you see docs.walrus.site, that's being served with the service worker. But if you go to docs.blob.store, that's basically being served with a server-based portal. So this is just kind of something I stole from the internet on explaining how this service worker works. But I'm not really an expert on front end, so if anyone knows how this service worker things works in browser, feel free to ask me. I'll pass it to the team there. So as I explained earlier, right? So there are two versions of the portal. Docs.walrus.site. This one is served through basically using a service worker. And blobs.store is served on a server. So some project ideas that you can think of is, support availability for L2s. Build kind of some kind of verification oracles if you want to go complicated there, right? And also storage of these archival for pretty much any blockchain, right? Walrus is a pretty generic, general purpose storage system. You can store anything there you want. Other use cases include some of the AI stuff that's pretty hot right now. Training data, data set, verified things that you wanted to store. Weights, vector databases, intricate detail there. Can all be stored on Walrus. The possibility, I think, is endless, and I'm really looking forward to seeing everything that you guys are building. So thank you very much. There is a question. Yes? What is the main difference between IPFS and Walrus? So IPFS does not use erasure coding, right? So when IPFS nodes go down, you might not be able to retrieve your file. And also IPFS basically outsource some of the storage to third parties. It's like Filecoin that actually stores the thing, right? So Walrus basically has storage nodes natively in the network. They actually store your file. And if being BFT, if a third of the storage nodes go down, you will still be able to retrieve your file afterwards. Yes? The Walrus site, so are the Walrus sites statically generated content? Yes, those are probably the best fit for that. But you can have some of the progressive web app things, like React things, hosted on Walrus sites as well. They will work. The only thing there that may not work are Next.js sites that uses some kind of server-side rendering. Those may be tricky. But if it's mostly static-based Next.js things, we do have a workaround, so come talk to us on the booth, and we can kind of help you out there. Yes?
So is there your recommendation for PWA settings? So PWA can be very different ways to approach. Do you have a recommendation for settings, like the offline support and?
I would think that for PWAs, progressive web apps, I think just a native, just pure React, that's probably has been tested. There is an example that is in the resources that we listed on ETHGlobal site. It's called example-walrus sites or something. Go find it there. As I said, the recommendation is to maybe not touch Next.js related things, but if you have to, come talk to us so we can help you out. Yeah. I would think so, yeah. Anything that's basically static that can be served directly from like a hosting solution that doesn't go through Vercel or server-side rendering. So I think anything that has server-side rendering that does some kind of, service and events may not be the best use case. Yes? Is it possible to store something from the client side, from the browser? Yes, if your browsers can make HTTP put requests, right? So you could. If you do it through the publisher, you're basically putting some trust into publisher, right? So as we talked before, publisher slash aggregator, they're the outermost part of the walrus onion, right? So they are a layer of abstraction. If you build a website that uses some kind of wallet there that kind of actually pays for these things, you will need to go like deeper into how Walrus works when it interacts with the contract and things. So that's more complicated, and we don't really expect people to do that in like a 36-hour hackathon. Right? All right, so I think time is up, but if you have more questions, come to our booth. Really look forward to talking to y'all. Feel free to scan this thing to join the Walrus Discord. And yeah, thank you very much.
Definitely, yeah. That's
My first hackathon. I'm
Okay.
from like an AI background,
Mm.
and like I just moved to San Francisco. I did like 3 AI hackathon, and they were all bullshit. So I heard that like got a lot of friends in Switzerland that were doing like blockchain stuff, and I heard about stories about Ethereum hackathon where people were deep diving in it.
In it, yeah. That's
So
good.
I try my shot today.
So
Yeah.
Good.
Sure. And so you're working at Ledger too?
Yeah.
You don't have an office in San Francisco?
No. Mostly in Paris and London for the R&D part. So yeah. And basically, we just wanted to present. So I'm going to talk to you directly. So we just wanted to present a little bit some of the ideas that you could tackle for the Ledger Hackathon, because we have a bounty which is very broad, which is best use of Ledger technology. And just to give a little bit of context, this is what we do. This is Ledger devices, hardware wallets. Okay.
Yeah. I'm a bit like I'm not
So-
fully digging.
Yeah, okay, that's perfect. That's perfect. Yeah. So basically, among the ideas of using Ledger technology, we've actually released a couple of SDKs that enable interacting with Ledger or extending Ledger technology for useful stuff. And basically, this bounty for Ledger technology is really about any kind of use of those kind of SDKs to build things around Ledger technology. So I can show you a couple of things. So the first one that can be interesting if you are familiar with embedded software development, so C or Rust. It's basically developing an application directly for the device. So this is here the pointer to the documentation on our website on how to build an app on the device. And it's pretty straightforward. You can just install something on an extension on VS Code, a Ledger extension on VS Code to build for your device. We have a boilerplate app which gives you an example of what it looks like, and then you can follow the documentation to add whatever you have in mind for a Ledger application. So that's a pretty good one if you are familiar with embedded software and you're ready to develop an app on the device. That's a nice one. So this is the first kind of ideas that you could tackle. Then second type of ideas that we've just recently released, like last Monday, we've released a new device management kit and device signer kit. So this is basically kind of a middleware that enables you to connect to the Ledger hardware wallet, and especially the Ethereum application on the Ledger hardware wallet. So if you are building a web application that requires any kind of Ethereum signature, you can directly connect it to the Ledger wallet through this device signer kit actually, and this device management kit. So it's in TypeScript, and it can connect through over USB or BLE to your device, and it makes it really easy normally to connect to the device. And we are really looking for any kind of feedback on the ability to connect to Ledger device and the quality of our documentation. So if you find anything that is wrong, just give us feedback. That's also part of the bounty to have the best feedback on our developer portal. Actually, that's the second category of ideas that you could have. And the third one, which I'm really keen on, because that was part of my talk at Pragma for those who were there at Pragma yesterday. It's actually how to clear sign on Ledger device your DApp application. So if you are a decentralized application developer, so you've developed your own smart contract, you've developed your own interfaces basically. The main issue that a lot of developers have is how do you clear sign those smart contracts, those smart contract calls on your Ledger device, or your EIP 712 messages on your Ledger device. This is something that is very difficult. And just yesterday, I don't know if you heard about the Radiant hack actually. So because of blind signing, Radiant Capital got hacked for $50 million actually. And typically that was because they were not able to clear sign on hardware wallets the interaction of their users. So this is really what we're trying to tackle, and we've recently introduced a stack to make it far more easy for the app developer to actually clear sign their interactions or their messages, and that's what I wanted to demonstrate today to show you what is being done. And we have a special, we have one prize among our 5 prizes which is dedicated to that. So if you are the app developer, write your own description file, and I'll show you how to do that. And that will be one of the prize for one of the bounties for Ledger for this time. So we try to make it very simple. So the basic idea is that you have a JSON file that describes how to format your smart contract interaction to users. So if you want to develop that, the simplest is to actually clone the GitHub portal from Ledger actually. So oops, sorry. Let me find it somewhere. So you just clone our repository, which contains all the clear signing descriptors. So this is the clear signing ERC7030 registry. Then what you'll get is basically a full registry of all the stuff inside. And I can open it actually on Visual Studio Code so that you can show what's in there. So this is the structure of the registry. So you basically have one folder per the app maker. And this is where you're adding your description file to describe a little bit what the app is going to look like. Let me just check out the demo folder, because we don't want to pollute everything. So we have a demo branch. So just to give you what it could look like. So for instance, this is the description file of how to clear sign an EIP712 message on a Ledger device. So let me actually create a new one. Let me call it demo 4. And use the template we have created to quickly create it. So this is the structure of the JSON file you need to write, and this is the only file you need to write as a DApp maker to clear sign one specific EIP712 message on a Ledger device. So once you've written that and submitted that on the registry, we take care of everything else so that you can actually clear sign your message on a real device. And for EIP712 message, we have everything ready at our booth, so that you can test on a real device what it will look like at the end. So here I'm going to show you the very first step, so that you're a little bit autonomous to start, but don't hesitate to come see us at the booth if you have more questions on that. So this is what this JSON file looks like. It's basically made of 3 parts. The context part describes a little bit what the file applies to. So typically here we are telling this is an EIP712 message that is part of let me just open Timo. Voilà. On va y arriver. This is just up. So this is because I've got all my values here. That's okay. So I can just, for instance, give the address of the smart contracts that will interpret this clear signing message. So here I'm putting another value. This is typically the domain of the EIP712 message. So I can use any kind of domain I will use there. Here, this is the schema of the message. So schema is really the structure of the EIP712 message you're signing. So this is typically, I don't know if you know the EIP712 specification, but it's basically the types the message is made from and the primary type that contains the message. So here you basically copy part of the EIP712 structure directly in the file, and this is what is used to bind this file to a specific message. So once you've done that, this clear signing file will only be applicable to messages that follow this type and are actually deployed on and verified by this contract address. So this is how we bind securely a message signing description to what will actually interpret this message. The metadata section is really displayable values that will appear on the device, used to can give more information about the owner of the smart contract and anything else that will be displayed on it. So in this case, for instance, you can put Ledger Hackathon as the owner of the device. The legal name is the legal name of your company in that case, or whatever you want to put there, and the URL the users will see when they interact with your DApp actually. So this is all this is actually going to be displayed afterward on the device, and you just have to create this file so that it's displayable on the device. Really something that makes it more easy to manage those kind of things. And after that, this is the meat of the description file. We have the section that is actually used to tell the device how you should display a message that comes here. Sorry, got the wrong. This is the schema I wanted to take, so I'm gonna take this one instead, rather than this one. Yeah, perfect. So here I have an EIP 712 message with just a single primary tab, which is permit-like. So I take the permit-like and I'm applying it to the very first here. So this is a format. This is a file format where we support multiple message schemas in a single file. But here I'm just giving you an example of a single schema, permit-like, that I want to describe. The intent is actually what the user will see as the main intent of their interaction when they're signing the message. So when they're going to sign the EIP 712 message for your smart contract, they will see they will see this main message on their device rather than the title of the message. So instead of seeing permit like, they will see a real line which is sign a permit to spend tokens, something like that. And then you get to the main description on how you format your message. So the first thing you do is you actually specify which fields are mandatory to display for the device. So here in that case, I want to display, for instance, the amount I'm authorizing to spend and the spender address, because these are the most important fields. And you can also specify in another section what not to show. Definitely not to show. So, for instance, the nonce here of the permit message is really is an information which is purely structural for the smart contract. Doesn't really need to be checked by the end user. Makes no sense for the end user to review. So we just exclude it from the UI, and the wallet won't show this field to the user. And all the other fields are basically optional. So whatever I don't specify here or here are optional. So the wallet decides to show it or not, actually. So I can tell you for now, on Ledger device, we show all the optional fields because we are more going toward the more secure version of things, but that's our decision. And then it will be the decision of the wallet to show optional field or not, based on settings of the user typically. So and then the main meat of the specification is really this fields section, which tells for every single field that you want to display. So in that case, amount, how you display it. So first, you provide a label, which is kind of the title you display before the field. So here I can say, for example, amount to spend, something like that. And I can specify the format. There's a list in the specification. There's a list of already existing formats. So here, for instance, token amount just tells the hardware wallet to display this field as an amount of ERC20 token. And when I want to display an amount of ERC20 token, I need two things. I need to convert the amount in the right amount of decimals. So if there's on Ethereum, there's like 18 decimals after the number, so I need to convert that. And I also need to have the reference of the token I'm transferring. And usually in smart contracts, this is transmitted in an address in the message itself. So here I just specify that, for instance, that the address of the token I'm trying to display is included in the token parameter here of the permit like. So this is what it means. So this is the first one. Another example is for the spender. So thanks Copilot, that is actually auto-completing a lot of things. So here for the spender parameter, I'm just saying this is the spender address. I will show it, and this is the format of the spender address. So basically, this is I should display it either as an address or as a name. For instance, if there's an ENS that corresponds to this address, the wallet will display the ENS rather than the address, which makes it far more easy for the end user to review the transaction. The expiration date is an optional field which I can display as a date, and the date as just a single parameter, which is the encoding. So basically, a date can be either, for now we support two types of dates. Either it's a Unix timestamp, which is very usual in the smart contract interfaces, or a block height. So if it's a block height, that means that the number actually represents the height of a block in the blockchain, and this should be converted as much as possible to a readable date for the end user by the wallet. So this is for expiration. And the last parameters that I have, so nonce, I said I don't want to display it, and that's all actually. So token is displayed as part of the amount, expiration is displayed as a date, and spender is displayed either as an address or as a name. So just by writing this file, you are able to control how it's going to be displayed by the end user. And the last part I wanted to show today is how you actually test this. On a real device, I won't have time, so I will tell you just go to our booth, and we can help you test that on a real device. But before, there's something fairly powerful. If you go, if you've cloned the registry, you can go to the developer preview folder. There's actually a local web application that is in this developer preview folder. Which you can run, which is Node.js application. So just install Node first, run npm install to install the dependencies, and then run dev. It will run a local version of this application, which actually takes the file you've just written and simulates what it will look like on the device actually. So when you run it, hopefully it's going to go fast enough, you can select the new file I've just created here. And here you will see actually what is the results of writing your file on a hardware wallet. Obviously, we've simulated ledger devices, but the intent for this is going to be to simulate any kind of hardware wallet that support our specification. So it will be really easy for you to immediately see what it will look like on various types of hardware wallets. So here we have a Ledger Flex and Ledger Stacks, but you might imagine later we will add Trezor, and you will be able to see what it looks like for Trezor device and any hardware wallet that supports this specification. And you can see that if I modify, I don't know, for instance, the label, that's the label to say allowance expiration, for instance. And I save the file. Let's not forget it. Then it gets reflected. In how it's displayed to the user here. So with that, you can really quickly test your JSON description file on a specific message or a specific smart contract call to see what it will look like. And the last part, once you've done that, is once you've done that, submit it as a pull request on the Ledger registry. And you're done. Basically, for us, you've done most of the work that we intend from the app developer. After that, we intend to basically we'll just quickly review the PR and accept it, and we'll generate everything that is required so that you will have the exact same message, clear sign, on your device at the end. Actually, so this is it. And basically, we are really trying to make it so that it's very simple for a decentralized application developer to write this file so that their messages and their smart contract calls are clear sign on hardware wallets, and so that we can really scale the ecosystem and make it so that all the interaction of end users with any kind of decentralized app is actually clear sign at the end of the day. And this is really where we need a decentralized application developer, because they are honestly, you are the best to write those kind of files. Hardware wallet makers don't know how a smart contract is designed, or what kind of messages they're using, so we are not the best to write this interface. The decentralized application developer are the best to do that. So thanks for listening to me. I think it's we are at the end of the workshop. And if you have any more questions, don't hesitate to come to our booth. We will be there for the 3 days to support you. That's all. Thank you.
I think about like a 1 or 2 minute mark, I can usually finish it up. Yeah, but it's, I mean, whatever. 5 is good. Just telling me that I'm at 5. So I'm gonna righty, you guys ready to rock? What's up, everybody? Thank you so much for coming. My name is Kevin Jones. I am a DevRel engineer working for The Graph. I work for Edge and Node, which is one of the core developers. I'm going to be talking to you guys today about why you should use The Graph, why it's important to have some data indexing, talk a little bit about how The Graph works, and how you can configure a subgraph really quickly. We'll try to build one as well using the Graph CLI. My name is Kevin Jones, again, based here actually in the San Francisco area, but you'll see me at a lot of events. Happy to answer any questions afterwards, or if we have time, I'll answer questions. So again, basics of like what is the graph and why you need it. We're going to show the configuration and the architecture and then do a demo. So first of all, why do we need data indexing? I think we know that like for something like Google or some of these larger search engines that are very Web 2, it's to categorize and make information easy accessible by searching. Same goes for crypto. Blockchain data is pretty complicated, and the fact is that you really need a way to easily access that data rather than using the built-in tools that are on the blockchain itself, like the RPC is what I'm referring to. And so if we talk about blockchains, blockchains are incentivized for transactions, right? You write transactions to the blockchain, you pay some gas. If you're a good smart contract developer, your smart contract emits events, right? That lets your front end know what's going on. And then these are kind of like cheap logs, right? We're able to kind of send some data and keep things aware from a global decentralized perspective. But these can get commonly or kind of lost on the blockchain if they're not categorized in a way that's easy to access. So we look at like an example, simple NFT, right? This is the CryptoPunks contract. All the CryptoPunks contract is a list of the IDs, the punks, who their current owner is, and then where the metadata, which is all the off-chain data, right, sits. So this is a very basic use case of kind of using the blockchain as kind of a little bit of a database. And as these owners of the contracts change hands, we need a way to be able to know what's going on and know who owns a punk at a particular time. But there's some problems when it comes to getting data using the standard like interface, the RPC interface. The first of all is there's just a lot in one given block. There's lots of protocols that are like, inside of a full block. And so it can be very difficult to just look up, like you have to know exactly what contracts for each protocol. In other words, like Uniswap, how many contracts are there? What are all the addresses? Keep those in your application and query them. And if you're trying to get lots of data from that particular protocol or multiple protocols, it's really hard to do. And we also have this idea of like an initial dApp where you have a user interface that you deploy with something like IPFS or Arweave, and you have the application sitting on the blockchain. And for writing, like I said, to the blockchain, using gas, paying for the gas, using the whatever consensus algorithm to secure your transaction is great. But when it comes to reading from the blockchain, technically the RPC is not designed for reading. It originally was used as a tool for people to query their node and do some kind of interesting things to see what was going on with the blocks. It's never really been truly created to solve this kind of data problem. We also have this problem with provenance. So how do we get like historical data from the blockchain? How do you know like what exact block number that someone sold their punk to another owner or transferred it to an exchange or whatever it is? There's no way to get that information, right? So what we really want is something like the time machine where we can go back in time and see historically. Does anyone remember time machine? Show of hands. Did anyone ever use it? I used it a little bit. But it's kind of a cool idea, right? You go back in time and see what's going on. We want to do the same thing with the graph. We also end up with like something like this, where someone wanted to see all of the NFTs in a wallet, which is like, this is definitely not an ideal way to do that. But if a user only has like 2 NFTs, it's great. But if they have hundreds of NFTs, it's going to be making hundreds of RPC calls to the node or to the RPC endpoint, and that's going to be very inefficient, as this is just trying to loop through and get all that data. So this is where the graph comes in, right? So we know the problems. The graph is over 200 indexers across the world that are indexing data. It's what are called subgraphs. There's delegators who provide stake. There's curators who provide GRT to incentivize people to pick up that data and store it. And there's this is a wrong number. It's actually closer to like, I think 10,000 subgraphs now. So there's lots of dApps using the protocol in a decentralized way. And there's a large amount of queries that go through the network as well. And so the idea is to take this, mess of a blockchain and create subgraphs for protocols and for dApps. And so create these subgraph configurations, which are basically databases with an API associated with them. So show of hands, who knows what an API is? Everybody? Who doesn't know what an API is and wants me to explain that? Basic understanding? Okay, cool. So what we want to do here is do something like this instead. Instead of doing that for loop, we can make one GraphQL query in one HTTP request and get all of the same data using the graph, right? And this is kind of the real beauty of the graph is everything is built around GraphQL. And if you're a front-end developer, you know that GraphQL is perfect for front-end development and especially for hackathons. So this is kind of what it looks like. User interface you have an indexing protocol instead of the graph for reading that data and indexing it and storing it. And you still are writing to the blockchain for all of your secure writes, paying gas and all that good stuff. Okay, let's look at the configuration. So the subgraph configuration is essentially 3 files. We will look at these files in a little detail, but you can think of it like this. The manifest is like the high-level configuration file. Just like any software, you need this high-level configuration file that keeps track of like what you care about. So what network you care about, what entities, how you want to store the data. It keeps track of the address. It keeps track of like how you want to handle processing data. And it kind of references these 2 other configurations. So it references the entities and it references the WASM handler, okay? The entities are how the data is stored. Like in other words, if you create an event, the event is emitting a data type and some data. The entity needs to be relational to how the data is coming off the blockchain's event. So you can think of it like how that data needs to be available to your front end with those proper data types, like integer, unsigned integer, string, Boolean, address, whatever it is. So that entity is actually a GraphQL thing, but it's basically, we'll look at it, but it's basically like a table. You can think of it almost like a database table and how you want to store that data. And then the third part is like this assembly script. So assembly script is a subset of TypeScript. So it's not quite TypeScript, but it looks like TypeScript. It has type safety, but you can't do like imports of like TypeScript stuff. You can only import the stuff that we support, which is like the GraphTS and a couple other things. But it allows you to create a WebAssembly module that processes the data, okay? And so that's what actually stores the data in the database, and that is what is used to listen for the events as they come off of the blockchain. So you can think of it like this. The blockchain application that you have, the smart contract, emits events. You also might have like an IPFS hash or something that's emitted for Arweave that tells you how to get the data from Arweave for it. So let's say it's like an NFT. So we can do off-chain data. And then the WASM will process that data as it comes off, or it will go out and get the data from IPFS or Arweave based on the event. And then we store that stuff with Postgres in the database, okay? So the data is actually stored on the indexer inside of a database. And then for the indexers, they also run a copy of what's called GraphNode. So GraphNode is a Rust implementation of basically, it's what runs the WASM modules and makes sure that they're running to process the data. And it's also what exposes the data in a GraphQL endpoint. So imagine your user or your consumer is going to your application. They're making a GraphQL request, giving that to the GraphNode over the API. The database is then responding with the appropriate SQL query data and then serving that as a GraphQL response. So it's kind of like middleware. That's the best way to think about it. So again, just review, this is like probably the best diagram I know that we have of explaining it, but you have a dApp, right? You build your dApp, Next.js, whatever, React, whatever it is, JavaScript, CSS, HTML, doesn't matter. You're still proposing transactions to the blockchain. You're still using that gas that you pay for to change the state. The smart contract is emitting events on the right, and as they get picked up by GraphNode, using the WebAssembly module, the rules that you have defined inside of that module, they're stored inside the database, and then they're exposed with the GraphQL API, right? So then your dApp is just able to query that GraphQL endpoint directly. Another good use case for you guys, if this is who's your first hackathon? Anyone here first one? First one? Oh, perfect. Okay. This is a cool package. It's called Scaffold ETH. There's a special extension for it. All you have to do is add -e subgraph, and you will get a copy of Next.js, Hardhat or Foundry, and a subgraph repo that has a subgraph already built for you for the contract that comes with Scaffold ETH. So if you're just starting out, this comes with everything you need to qualify for the bounty. You just need to make changes to your subgraph and make changes to your smart contract that relate, and you can get started quickly building a dApp. I'm going to use it in my demo, but yeah, we'll go from there. There's also a Telegram chat. Everyone who wants help, we have a booth. We'll be there. For some reason, there's no one there. Should join the chat. There's not a chat channel yet, but we will create that right now. There should be a general one, though, so if you have questions, you can ask in there. Anyone need to scan that? Cool. There's also cheat sheets. I don't know if we have them here. We probably don't have them here, but they're at the booth. Those are going to be super useful. You should come grab one. They're going to help you get started pretty quickly as well. Okay, let's do it. So I got 9 minutes for a demo. Cool. Okay, so I am basically going to I've already deployed an application with Scaffold ETH. I put it on base mainnet. It's a very basic contract. We can look at it right here. Well, actually, we can look at it in VS Code because it's a little nicer. It's like a hello world contract. The only thing you need to know about it is that it displays a greeting. This is the contract that comes with Scaffold ETH. It displays a greeting called Building Unstoppable Apps, and then it emits an event anytime someone changes the greeting. So if they come in here and set a new greeting, they kind of shout something, then it emits the event, right? It's a very basic smart contract, nothing crazy. So I've already deployed that, and if we come over here to Scaffold ETH, we can see that it's actually deployed to base. It doesn't have any balance, but it has a string of hello, ETHGlobal San Francisco, right? So we want to index the data for this contract. I also verified the contract already. So if you click here on contract, you should verify your contract before you deploy it, or after you deploy it, not before, you can't. But after you deploy it, you should verify it because the CLI will reference the ABI to make sure that it understands all of the events that are in there, and it will automatically build you a subgraph. If you don't verify it, you have to pass the ABI in the CLI, and I'll show you what that looks like right now. So if you're going to get started on the graph, and let's say your smart contract developer has built the smart contract, or you've built it, and you want to build a subgraph for it, you come here, you go to thegraph.com, you go to products, you go to the subgraph studio, okay? This is where you go if you want to build a subgraph, okay? If you want to query a subgraph that's already out there, you can go to the Explorer, okay? So it kind of depends on what bounty you want to get. There's 3 bounties. There's the best use of a subgraph, there's the best new subgraph, and then there's, I think, best substreams. So there's 3 different ways that you can qualify. I'm not going to talk about substreams today, but you're more than welcome to come by the booth and I'll explain some things about it or afterwards. So really, if you're going to get the new subgraph, you should be going to the studio. So let's do that. Let's go to the studio. You'll sign in. So if it's the first time you've ever been here, you should sign in. You connect your wallet. It's going to ask you to sign a message, create an account, and you'll get on this thing. You'll get a free plan with 100,000 free queries. Oh, for some reason I have 200,000. Sweet. And I will say create subgraph. I will name it. So we'll do it ETHGSF or something. I don't know. There we go. It will create it here. You click it. Okay. You install the CLI. So it gives you all the commands here. This is kind of like a skeleton, like a bare bone skeleton for you to start building. So you come over here. You can install the CLI with NPM or Yarn. So let's just say we do Yarn. I've actually already done that. So let's skip that. Then you do a graph init. So we come over here. We do graph init. That's going to spin up a new subgraph on my local machine. So I'm in my terminal right now. I'm going to go to Ethereum. I'm going to call it ETHGSF, ETHGSF. I'm going to go down and choose my network. So in this case, it's base. If I can find base, where's base? Here it is, base. And then it wants the contract address. So if you've deployed your contract, it's available, right? You know what it is. you're verified, go here to contract, grab the contract, paste it in. It's going to try to fetch the ABI. It might have issues on certain chains, so you might have to provide the ABI. So if you want to do it manually, you say no. It's also going to try to fetch the start block. If it can't find the start block, you might need to add it manually. I'll show you how to get that, so we'll say no. So where is the ABI? Well, I have it in my project here. So it's inside of the artifacts, I believe. No, sorry, it's in deployments. Here it is. So here's the ABI. So I have that. You'll need that if you are on a chain that isn't pulling it automatically. Ethereum mainnet, it should, or like Sepolia, it should pick it up. So you should be fine. So I'm going to copy the path, paste it in. The start block is available on the block explorer. So you can see here, this was the transaction of when this contract was deployed. We can click it, and then we can get the time that it was deployed. So this was the block, so I can grab that, paste it in, name contract, index of entities is true, yes. You always want to say yes, because that will build out the subgraph for you. 4 minutes. Let's do this. This last part's going to be a little bit of a speed run. Because I'm going to have to fly through the explanation. But okay, add another contract, no. I'm going to go into that folder, so ETHGSF, and I can take a look at the code. Let's look at it real quick. So I mentioned earlier, there's a subgraph YAML, which is like the high-level configuration file. It automatically generates this as long as you provide the ABI, and as long as you, if you verify your contract, it might do it automatically. Otherwise, give it the ABI. This tells you what network we're on. So we're on base. We have the address. We have the start block in here. We have the entities that are automatically created based on your events. We have the handler, which processes the data, right? Those 3 things I told you about. So if we go to schema, we only have one entity, and it keeps track of the ID, which is like the actual ID of the unique identifier, which is generated. It has the who sent the greeting, what the greeting was there a premium paid, was there some value in the transaction, what was the block number, the timestamp, the transaction hash, and all the data types that we know we need to use based on the ABI. And then inside the source folder is the contract TS, and this is where the handler is processing the data. So we import the schema, we import the contract and the event, and then when an event comes through, creates the entity using the new function here, creates what the ID should be, the hash, and converts it to I32. And then we set all the values as they come off of the block. So the event parameter for the greeting, for the new greeting, the greeting setter, the new greeting, what the premium was, or did they pay a premium, what was the value in the transaction, what was the block number, the timestamp, and the transaction hash. Okay, so let's deploy it. So I'm going to do it real quick. Subgraph Studio, auth, did I already do that? No, I didn't do that. Let me auth. I have to authenticate, then I can build. So this is going to generate the types for me so that I can interact with the contract, and it's going to build the WASM module, and then all I need to do is deploy. So it gives you all the commands. You literally just have to copy, paste, copy, paste. So version, this is the last part. It asks you what version you want. Let's do version 1. Now it's going to take the subgraph, deploy it to the network. Now it's going to deploy it to the studio, I should say. And then it's going to give you the API endpoint, but we can also grab it just from the studio up here. So now it's synced 100%. We can go to Playground, and we can start getting the data. And there it is. So I only have one event, and it's hello, ETHGlobal, San Francisco. I didn't pay any value, and I was the one who set the transaction. Cool. So you get the idea. It's pretty easy to get started with the graph. You just need to come onto the Graph Studio, create a subgraph, follow those commands, and it will build the subgraph for you. We obviously want you to do more than that. Like, you should probably do some interesting things in the subgraph. There's tons of features and functionality. But yeah, hopefully that was useful. I have time for one question. Who wants it? Not one question? Yeah. So when I deployed this one, the question was, is where does the step graph live? In this case, I'm deploying it to the studio, which is a special setup that we run to run it like a development environment. When you eventually publish it to the network, it goes onto the decentralized network. But here, it's on a special kind of like development instance, but it's not on your local machine. If you use the subgraph extension of Scaffold ETH, that will give you a Docker container that you can run locally. And that's an option. Cool. I'm going to step outside and answer any more questions you guys have, but thank you so much. Appreciate it. Oh, thank you.
Are having such a good time. Um, Let me do it quick. We are launching here our white label APIs. This is the first time that we're publicly speaking about it. And you know, the hackathon will have 3 challenges. Feel free to interact with our APIs, and we're talking a little bit about that in upcoming. But yeah, it's about checkouts, crypto checkouts, NFT checkouts, and domains. Like, there might be a way. Like, the idea is you to hack our wallet identifier system and integrate it with ENS. Currently is not available, so that would be part of the challenge. So a little bit about Unlimit. So we are all-in-one payment company, basically. I mean, it started formerly known as CarPay in 2009. It started and becoming one of the most important players in Europe. Currently, we are the biggest player in Europe. We got global presence, not only over there, but also in Latin America, Southeast Asia, Africa, and of course, US and Canada. As a legacy company, we hold acquiring licenses across Europe, Mexico, Brazil, also Hong Kong, and more than 5 pending. We offer payment methods in our traditional services, so we are trying to leverage those payment methods as well here in the ecosystem. Those are more than 1,000 payment methods, including obviously credit cards, but also local merchants. IBAN accounts, we are focused in cross-border payments, as well as the possibility to create IBAN accounts in Europe. We're exploring to open it up and wind it up into more jurisdictions, but currently it's available there. And the card issuing, we are also having a special crypto-backed credit card program that it's in the beginning was only available in Europe. This quarter, if we open it up in Mexico, next year will be opened in Brazil as well. So then why we decided to tap into the market. First of all, obviously, we all know here that the cryptocurrency market is worth more than $2.4 trillion. Currently, it surpasses economies such as Canada or Japan. So it's impossible to keep ignoring it. And Unlimited was visionary enough to start building the widget 2 years ago and then launching it officially in less than a year and a half ago. So we're having this pathway. It's still the incipient stages, but we already are creating it. How it works, a little bit about how it works, the whole checkout experience. So basically, you're a card holder, you want to buy in an e-commerce or whatever, you go to the store, the merchant, and the merchant will have a POS system. That POS system connects you to a processor. It might be a third party like Square, and that processor has an agreement, a relationship with an acquirer, let's say WorldPay, and the WorldPay has a relationship with the networks, obviously MasterCard, Visa, UnionPay, JCB, or others. That network immediately asks your bank account whether you have sufficient funds or not. If it's sufficient, well, the response is like a processor transmits the message, and the POS gives the final response to the merchant, and the transaction is complete. So basically, that's the traditional structure, and that's how it works, how it's been working like for the last 2 or 3 decades. What is our secret spice? Unlimited has in any it has an upstream, downstream integration. So in any endpoint of the whole value chain equation that I just showcased you, we do have a department, and we do have a person or a group of entities that are in charge. So for instance, if we're talking about the case of the card holder, they do have a card holder, they do have a third party that is not a principal member of Visa Network, MasterCard, like we are. They have a third party processor, such as Stripe, and they have a third party acquirer, such as WarPay, whatever. That happens with MoonPay, that happens with Bangza, with the others, you know? But on the contrary, what we do have is we are principal members of the networks, Visa, MasterCard, UnionPay, JCB, even Discover. And we are processor, where we have our own processing services or infrastructure back in Europe, but also in Latin America and Southeast Asia. And we are our own acquirer, as I mentioned it to you before, in more than 5 jurisdictions. So that's why we are offering like one-stop solution to the whole ecosystem. We're aiming to embrace the next generation of fiat on and off ramps. And obviously our coverage is more than in 150 countries in credit card acquirings and debit card. We have more than, team more than 10 languages available, more than 1,000 payment methods, 30 fiat currencies that we are offering, and more than 50 crypto assets across 12 different networks. All of that will be available in the API docs that will be shared with you. Basically, yeah, we are the third generation. We're playing this game as a first mover early in terms of like such as a Stripe, we hold the whole equation, the whole points in the equation. Stripe has been more timid. Stripe has been more shy to full-fledged, the whole deployment in a transaction. It's only available, for instance, in the US and for Polygon Solana. On the contrary, we are available across the 5 continents. We offer more than 50 assets and in more than 12 different networks. So it's a pathway that we already got. And we are surpassing these second generation competitors. Some of them, they're not even more in the market, such as Prime Trust or Wire. But the lack of the acquiring licenses, the gap of the integration of the whole pie. And this is a matter of, fees. So this is a battle regarding fees. And the more pieces in the puzzle that you have, the more leverage you have to lower the fees. And that's why we're here, and that's why we're here for the long term. So what's next? Of course, what's it about, the hackathon? We need to launch checkouts and obviously ENS domains as well. The checkouts. Important about crypto to fiat checkouts is it should be a seamless conversion. We're talking to approach the non-crypto related businesses in e-commerce. That's the 95% of the market, the whole market, digital market that we need to address. And that it allows a user who has cryptocurrency to immediately pay in crypto without the need to, go directly to a widget, only paying in crypto. It can be stable coins, it can be digital asset, and it is automatically converted to fiat and settled, and the merchant only deal with the fiat. Some merchants, some businesses, they don't want to deal with complexity. So that gives them, the broader accessibility to more people that are not tech savvy like us, perhaps, but that's the majority of the population, and that's the majority of the businesses, the people from the guy from the deli, the guy from a grocery store, the barbershop, et cetera, et cetera. Those are the businesses that we wanna approach. What's our advantage of, as I told you, is global reach. Our competitor is solely focusing in the States. We are with a widespread presence in Europe, LATAM, North America, Asia as well. We not only accept stablecoin transactions in Ethereum, Solana, and Polygon, but also in more than 9 EVM compatible networks. Avalanche, for instance, Arbitrum, Base, Binance Smart Chain as well, and more available in the API documentation. And well, with our APIs that I'm going to showcase, well, we offer that integration options to the merchants. NFT checkouts, it's another possibility as well. It simplifies the transactions. Basically, it gains same story. A guy who's a car holder and wants to purchase a skin or a trump card in Gods on Chain or every available NFT marketplace, every collection. He wants it to just have the card and maybe have the NFT and maybe, in the future have a more crypto-centric experience. But right now, as a first touch, just want to purchase. Those are the guys that we need to onboard more. That's the next 1 billion people that we need to onboard. It lowers the barriers. The technical barrier still exists. So we need to, again, the unbanked population, the people who doesn't crave for the technology 24/7. Those are the ones that are 95%, 97% of the population and the whole market. We need to grab a little bit of that chunk, that huge chunk, and that's the way we can broaden the presence and the adoption. And the last thing is it improves approval ratings. Currently, cryptocurrency is being considered as a high risk for the merchants. So if we process via digital goods instead of cryptocurrency in the MCC codes for the credit card transactions in the acquirers, they allows us a bigger, likelihood to get approvals in the transactions. Name extension wallets or domains, it can be either way. ENS, it's obviously the more popular, but also it can be free name, it can be FIO, it can be, there are several others. Uniswap has its own domain as well, Coinbase as well. And it's obviously it's a virtuous cycle in the UX because the user only needs its aliases, and that's it. Its alias is that links his whole experience, his whole wallet, to every other decentralized app or every other interaction that they have on-chain. And of course, it gives them the compatibility to top Ethereum applications such as NFT Marketplace and so on and so forth. Some ideas that we do have? It comes naturally, intuitively sometimes. It's e-commerce checkouts using credit cards, of course. Crypto checkouts using either credit cards or APMs. We do have access to local APMs, for instance, in Mexico. We do have cash vouchers in Peru, in Colombia, in Ecuador. In Brazil, we got Pix and PicPay. So we get several other integrations. And NFT checkouts, it can be for events, it can be for tickets, it can be for travels. And last thing, why don't kill two birds with one stone? There's either ENS domains, hackathon is already ongoing as well, or Uniswap. Uniswap has also domains as well, and they got another hackathon here, so why not? It's time to jump into conclusion. So let me showcase you guys the white label APIs. If you guys anything, if you anything question, just drop it to me, and I will answer it via Telegram or wherever. But yeah, you can customize functionalities. Basically, you can customize and personalize your KYC process. You can generate quotes, and everything comes along naturally with your own UX and workflow. So you don't need to mold or you don't need to adapt your whole workflow or whole experience to our widget. Now you can create and personalize the widget with your own branding, with your own recognition, and with your own mantra. And the sandbox environment is available for testing with USDT, USDC, and Ethereum. And USDC and USDT will be available not only in mainnet, but also in Binance Smart Chain. These are the sources of the hackathon that they will be available also in the dashboard, in the ETHGlobal website. The white label docs, ask me just after the presentation, and I will give you direct access to them as well. But we do have also the API docs here. Last thing, this is my Telegram. This is my Discord username. Feel free to reach out to me. And, I wish you all the best, and may the odds be ever in your favor with this hackathon. All right. Any questions or? All right. Just last one. Yeah. Go ahead. No, for as of now, yeah, you can check it out here, and the white labels. The white labels here. It says it's only I think in Binance. Binance Smart Chain for now. In production stage, we do have. As a product, we do have in Polygon as well, USDC and USDT as well. I even die in Polygon as well. All right, thank you.
challenging problems that work at the intersection of blockchain and cryptography. So yeah, really, really excited. This is like a relatively fun idea for us, which is blending robotics and blockchains. And we think there's some values that blockchains share that are incredibly useful for building robotic systems. So yeah, why robotics? Well, yeah, we envision a future where robotics are going to be operating in unconstrained environments. So today, they're typically deployed in factories. These are highly constrained environments. And of course, the rules inside the factories are very different to the rules for robots operating in open systems. So concepts such as safety become critical. I'm sure we've all been in a Waymo. I mean, if you put your hand up if you came here in a Waymo. Yeah, quite a few of us already. So we're all pretty familiar with just how dangerous these devices could be if they malfunction. The second piece is we think robots are going to be operating in collaborative environments. And this means that humans are going to be working alongside robots. And it means we are going to be placing a great deal of trust in the robotic systems that we're going to be interacting with. And the third piece is we think these interactions are going to be routine. They're going to extend into our homes. They're going to extend into the open environments around us. And in 10 or 15 years' time, it's not going to be unreasonable to expect that we will probably be interacting with robots on a day-to-day basis. I mean, in San Francisco, people already do. They take taxis, robo-taxis, and there's no human operators, no human drivers. So this is very much a reality, and it's going to become global. It's going to become ubiquitous. It's going to become widespread. And yeah, we see this. There's some very exciting hardware being developed today. These are all single-operator hardware systems. You can see there's UASs. These are zipline drones that can autonomously navigate in remote environments. We have humanoid robots. Just a few here is the Figure robot, which is the top center. We have the Chinese variant of a Figure as well. And we also have the 1X system, which is designed to operate in homes. It's a kind of more of a safety-considerate robot. And then, of course, we have the self-driving taxis, which are potentially the most lethal systems of all of these, just because they have a lot of mass. And so, obviously, when we think about multi-operator robotics, where we have multiple different robotaxi operators, for example, they might want to securely share information with each other. And they might not also be able to communicate with each other. They might not be connected to the network. There's potential attacks and exploits. So having some form of localized form of trust is going to be very, very important. And yeah, as I spoke about this before, the penalty for failure is extremely high for robotic systems. If a software system breaks, if a web server hosting my website, or even say all of the validators hosting a blockchain fail, in AWS or in a server or a data center, or maybe my bank servers fail, really the ramifications, the penalty for failure is maybe I can't pay someone, maybe somebody loses a little bit of money. It's not great. And there are some environments where software systems are critical, like in medical. But when we talk about physical systems and failures of physical systems, which are underpinned by software, then the ramifications or the penalty for failure really are catastrophic. If a car crashes, it could result in loss of human life or fatalities. So these problems are immensely important. They're immensely valuable and somewhat underappreciated, actually, in my opinion. I think people get very excited about this kind of unconstrained open tech, but they don't really seem to make a lot of considerations about safety. And as always, failure is to be expected. So unfortunately, devices might work, 99.99999% of the time, but it's that edge case that is still going to result in the system failing. And I kind of like the kind of trolley problem analogy. It's nice to know what kind of decisions a robot made. This is maybe more of an ethics question, but having some kind of immutable record where you could store information about robotic decision making and other robots around it and other humans could verify and audit that robotic decision making, that they could prove that the decisions made by the robot were made by a model that's been validated, and they can prove that the hardware was never tampered with, is going to become really, really important. Because when we have lots of these robots, we have very, very complex scenarios which might arise. And these robots need to make autonomous decisions. And as you can see here, this is maybe very kind of a very jovial representation. But yeah, we have lots of trolley problems in very complex environments. And so what are the kind of guarantees that blockchains can provide us with? Well, really, there's tamper resistance. So we can publish signatures about physical hardware to prove that the hardware is running a certain type of software, that the hardware itself hasn't been tampered with. And we could publish that to an immutable ledger. So that's very, very valuable. The second piece is we can authenticate messages. So we can authenticate the source or the origin of a message and tie it back to a physical device. And this really brings in concepts such as device identity. And we're really, really interested in really how we can create large networks of device identity, similar to what World is working on. World is working on a human identity platform, Proof of Humanity. And it's not unreasonable to expect that we could create platforms or basically primitives for robots to be able to communicate with each other on blockchains and share information or signatures securely with each other. And the last piece is really state conflict resolution. And I think this is really, really cool. There's things, concepts such as UTMs, which are unmanned traffic systems. And when you have very large networks of operators, you may want to create like an economy around the provision of airspace for drones, or an economy around the provision of terrestrial space, of notion of traffic for autonomous cars. How do we prioritize the actions of autonomous vehicles? And something like an ambulance, for example, might take precedent over myself commuting to work. And there's many other examples here where we can apply these kind of economic systems and economic concepts from blockchains to robotics and robots operating in open environments. So this is super, super exciting stuff. And of course, this is really scratching the surface of all of the potential applications and intersections between blockchain technology and distributed ledgers and permissionless open distributed ledgers, such as Ethereum and all of the scalable rollups, and physical hardware. And I think we're at a really interesting intersection, a really interesting point now, where we're now reaching beyond the kind of the virtual trust boundary and exploring the kind of physical realm of bits and atoms. And this is really, really exciting point in time where there's lots of these robotic projects and actual applied demonstrations of robotic systems such as Waymo taxis. And yeah, I think this is going to be very, very exciting over the next couple of years. So with all of this in mind, with the kind of the problem space I spelled out, we have given some ideas. We purposefully left this quite vague. I wouldn't say vague, but maybe open, actually, just because we want to give people the space to explore really any idea that's potentially related to robotics. And you don't need to scratch, you don't need to dig really into physical hardware systems, but even ideas that touch ML, machine learning, and the models that might run on robots are also highly relevant to this hackathon. So the first one was robotic identity. Now, robotic identity we think is going to be really, really important. In a multi-operator system, say we have large distributed autonomous taxi networks, there are a lot of kind of concepts that are required around ownership and control of the robots that are really going to be underpinned by identity. And this is things like, who owns the robotaxi? Where's the value accrue to? If the taxi crashes, for any situation, where does the liability, who's responsible for liability for an accident? And so having a kind of immutable, verifiable on-chain credential system that is also tamper-proof, which means that, I couldn't extract the chips from my taxi or my friend's taxi and put them in my taxi, and try and spoof the system. These are immensely valuable, and we think about these as kind of a primitive where blockchain is highly relevant. It's a really, really, really good use case, and it's why we think this kind of these proof of humanity identity systems can really be extended into proof of machine or proof of AI kind of model systems. The second piece is secure communications. So blockchains are very good for securely sharing messages with a network. And we think that open peer-to-peer vehicle-to-everything communication networks are going to become really, really important. Now, there are attacks today which are highly relevant here. A lot of the systems that we use depend on these kind of centralized or semi-centralized communication networks to share information. And these include things like 5G and 4G, and they also include GPS, actually, to passively receive location information. So in a scenario where a sophisticated attacker might use a jammer, a low-cost jammer, to jam out 5G radio waves or 5G frequencies, or jam out the GPS frequencies, these robots really can't operate at all. So if there's methods for robots in their local vicinity to securely share information with each other, and also prove that that information is trustworthy, that it was perhaps derived from real sensors rather than synthetic, and wasn't spoofed, again, that would be a very, very valuable use case of blockchain. It takes advantage of immutable ledgers. It could also take advantage of an identity system. And some of the other ideas that extend into this are really around decision making. You might have a swarm of robots, so you have like a search and rescue swarm of UASs. How can they efficiently allocate tasks to each other over what kind of areas they want to search? And the last piece is really shared learning. And this is maybe applicable in closed environments, but also very applicable in open environments. The world we live in is not stationary. And this is particularly important in kind of, if anyone who's here has ever worked with geographical systems, maps change all the time. The world around us changes all the time. New buildings are built, roadworks are put up. The world is a very dynamic place. And it's very important that these systems are able to share securely information about the dynamic world around us. And again, we think that using a blockchain, using an immutable ledger, an immutable record is a very, very good use case for this. One of the ones that I really am a massive fan of is secure hardware and verifiable computing. And this is really about providing guarantees and assurances to end users about the integrity of a process on a piece of hardware, the correctness of the software it's running. And there's some really, really exciting tech. This is really at the intersection of, I'd say, hardware manufacturing and also cryptography. And here we can verify that, if you stepped into a taxi, a robotaxi, for example, this is one example, you could verify that the model the taxi was running was like a canonical version of a safe, formally verified and pen-tested and correct self-driving model. Or the model itself hasn't been tampered with. It's not beyond the realm of the imagination to think that some nefarious actors could potentially interfere with robotaxis and cause a great deal of harm. So being able to verify the integrity of the hardware, the software systems would be really, really useful. And the last piece is actually supply chain. As we start to kind of get more and more interested in trusted execution environments, the root of trust is something that's really, really important for TEs to verify that the observability of the private keys or the puffs, or we call them physically unclonable functions, which is a physical measurement which is made over a device, is secure, that it hasn't been tampered with, that some nefarious party isn't aware of this very important element of the hardware, which is used to derive a secure cryptographic key. This is really, really important for trusted execution environments. It's still kind of like an unsolved problem. And we'd be very interested, this is more of a theoretical one, in hearing people have like supply chain applied blockchain solutions. And the last piece is data provenance. And this is really, really poignant. I'm sure some of you may have seen the World Conference yesterday. There was a very cool kind of demonstration of proof humanity and how it could be applied to verify someone using a deep face model on Zoom, or verify if they were using a deep face model, if they were real. And this is going to become increasingly relevant in the future. I mean, these kind of models that can change your face are really, really lightweight. I can go on GitHub and find about 100 of these. And it's really, really easy now to generate synthetic data, and it's quite scary. There are some real political kind of ramifications. I mean, we're approaching election season in the US for this technology. And so being able to verify that information was collected by a physical device, by a real device, by a camera, is a really, really, really interesting concept for us. And we think for robots, this also extends into the kind of autonomous agents realm. Robots might want to share sensor information with each other and be able to verify that that information was untampered, that it was collected by a real sensor, a real device, is really, really important to make sure, in this big, unconstrained, open environment, that the robots are all using real data. They're not, trying to trick each other or trying to manipulate each other. And yeah, so this is the hackathon. We're really, really open here. You really just need to incorporate some use case of a blockchain. It can be ECDSA, but really, yeah, we can be even more open than that. And the submission doesn't require you to actually build any hardware. We appreciate 2 days is not a lot of time. And really, we want you to create or come up with an exciting, interesting use case of blockchain that is relevant to robotics. And yeah, we'd just love to hear what people come up with. Genuine, original, kind of innovative ideas are going to be the winners. And of course, there is a bonus if you can create a working prototype. It could be something that runs on a phone. It could be something that maybe runs on a piece of hardware. It would be super impressive if any of you have brought hardware with you, like a drone or a small robot. And yeah, really, really interested to hear what people have to build. So great. Does anyone have any questions?
How do you apply this robotics environment to blockchain? Can you explain a little bit more on that?
Yeah, there's quite a few kind of open libraries. There's ROS, Robotic Operating System. And ROS is currently used for sharing secure messages inside of a robotic environment. It's basically a Linux operating system. And there are a couple of libraries, I can share them, which can be used to publish these messages on chain. So that's kind of like quite a good starting point. But again, as I said, this is quite like an open book, hackathon. There's also some prior art around data authenticity and provenance. You might have heard of the Content Authenticity Initiative, which is backed by some very big names such as Adobe and OpenAI. And that's kind of an open standard for generating these authenticity or provenance signatures. So that's also a very good place to start. But again, it's not kind of blockchain native. It's for a very narrow set of use cases. And so we're really looking for people to take either original new ideas or existing technologies and extend their use case by applying blockchain. Yeah, so here, proving decision-making process, proving that a model was behaving as it should, the output is correct. This is something that you can kind of already do with LLMs, but it's also something that could be extended into a robotic system as well. Sorry? Of course, yes. I'll share these slides afterwards if you come up and... Yeah, so yes, yes. So the Apple uses trusted execution environments, and what they allow the guarantees they provide to users is that users can share basically encrypted information with the trusted execution environment. And the trusted execution environment can securely decrypt the information, perform a computational process, and then re-encrypt the output. And this is really important because ZK is not very good for very computationally expensive processes, and fully homomorphic encryption hardware just doesn't really exist yet for these kind of complex processes. So it provides a guarantee that the process running inside of a physical hardware is non-observable to an external user. And this might be really, really useful for robotics use case.
I understand. This is
Yeah. Yeah, they use something called a physical or physically unclonable function. Yeah. Yeah, I think those functions, the device ID, the serial, could be a very good basis for a robotic identity system. Exactly. Thank you, everyone. I think we're on time, but great. Thank you very much, and look forward to seeing what you come up with if you choose to work on this hackathon. Great. Thank you very much. Thank you.
Hello? Oh, here we go. Hello, everyone, both in person and online. Thank you for coming to our Sign workshop. I am Jack. I am the CTO of Sign Protocol, also known as a overworked developer. And I have my colleague Jordan here. I'll let him introduce himself.
Yeah, hi, my name is Jordan Betancourt. I am the prototype development lead at Sign Protocol. So for me, I play with a bunch of new technologies and just see how those things will integrate well with ours. So I'll talk more a little bit later, but I'm going to pass it back to Jack.
Yeah, and the reason why we're here today is because obviously we're giving away money at this hackathon, and you like to get that money and maybe learn more about who we are. So for us, we are Sign. If you have been in this space for a while, you might know us as ETHSign. We did like a minor rebranding because now we've expanded past just like the EVM network, so we decided to call ourselves Sign. And our mission is to build a decentralized proving protocol that brings off-chain identity, ownership, and consent on-chain to accelerate tokenization. Okay? So basically, another way to think about it is that we're trying to build an on-chain open data repository that allows anyone to post information in an open manner on-chain, in an open, structured, and indexable manner. We provide an indexing service to our developers. So basically, just on-chain database is a good way to think about it. And also, if you know us, you will know that we had an old product called ETHSign. It's still here. It's basically on-chain DocuSign. We have another product called Token Table, which is on-chain token vesting for investors or airdrop distribution. But for this hackathon, we're focusing on Sign Protocol, which is what I just described, the on-chain database. Okay. So the way that Sign Protocol really works, and we don't have too much time, so I'll be brief with this. And you can find us at our booth, and I can go over all this in much more depth. But basically, the idea is that in order to post some data on Sign Protocol, first you have to create a schema. So a schema basically defines, well, let me put it this way. So the data that you actually post onto our protocol are called attestations. So you can think of them as database entries. But before you add entries in the database, you have to first define a database schema. So that's also what you have to do first here. You have to first define your schema, which basically has a lot of metadata that about the attestations that you're going to make. For example, if they are revocable. For example, do they have like a set expiration date, things like that, or their data format, right? And in like JSON format, so it's human readable. And once you do that, right, you then are able to create attestations under that schema in order to basically actually start writing data onto the blockchain. And not only the blockchain like EVM chains, but we also provide a more cost-effective solution, which is posting data on Arweave. You're able to index everything just as well. We provide an indexing service called SignScan, and basically, it's 100 times cheaper, right? So you can actually post pretty heavy data up there. So this is a diagram, and this is available on our GitHub. I'm so sorry, everyone. This is available on our GitHub examples. Okay, I will actually quit this, and I'll find a place where I can actually zoom in. I'm sorry for the light mode. That's Jordan's fault, not my fault, actually. Also, he scrolls in the wrong direction on his laptop. Oh, I'm sorry. Ooh, almost showed something sketchy there. Okay, so we have three different identities, kind of, in Sign Protocol. You've got the schema creator, you've got the data consumer. I keep scrolling in the wrong direction because. And the attester, right? So in the beginning, before any data can be posted, you first have to create the schema, right? So these are the steps. First, you have to create, so there are two ways. On-chain schema just means it's saved on like a chain like EVM or Starknet. And off-chain, it just means like Arweave, right? I'm just using those terms to not confuse people, right? And when you create an on-chain schema, basically you have like this block here. I will zoom out a little bit, okay? So we have the Sign Protocol registry, and then we have the Sign Protocol smart contract. You have different schemas. And as you can see from this graphic, right, the individual attestations actually belong inside the schema, right? And here's this interesting thing that I didn't really talk about. There's something called a external hook contract. So when you're creating a schema, you're able to define a hook contract, which is basically an external smart contract that every time when someone tries to make an attestation, their attestation data will go through the hook contract. And that hook contract will have access to all the context, like the schema ID, attestation content. So they can do like data validation, they can do checking, they can call like other things, you know. So it's just anything that you want. You just have to conform to an interface. But it does have to be defined when you first create the schema. And the schema once created cannot be modified because like if you create a schema and people make like 100 attestations on it and then you change it, should we invalidate the first 100 attestation, right? It doesn't make too much sense. Okay. So once we're done creating the schema, and also like the Arweave version, because it's not based on smart contracts, unfortunately there is no schema hook functionality. So next, right, the attester. Okay. So what the attester does is that it will either go through the Sign Protocol smart contract or the Sign Protocol API. So the API is more for the Arweave stuff. Right? If the schema is not on Arweave, then most likely your attestation won't be on Arweave. So you go through our smart contract, and then you basically just call the attest function with an attestation object, which contains a schema ID among other things, right? And if there is a hook defined, then your data will actually pass through the hook. Okay. And then as a data consumer, well, you just like query, right, through the smart contract or through our API or through SignScan, which is our aggregated singular API. It covers all the chains that we support, so it's like we make it pretty easy for our developers. Okay. So let me give you like I'm so sorry, quick walkthrough of. So first, let me show you what a schema looks like. So this is one of our users of Sign Protocol called Holonym. So they are a ZK-based KYC provider on Optimism, I believe. So they've been using us, as you can see, pretty regularly, and they've racked up quite a lot of attestations. And this is the schema, okay? So and this website is our SignScan, so it's like EtherScan but for Sign, right? So you have the schema name, schema ID, the full schema ID, which contains like some more information about like which chain it's on, all that kind of stuff. And you have a description. You have the creation date. You have maximum valid time frame. Now, English is my second language, so I wasn't sure how to properly phrase this. I don't know if I can phrase it better, but that's basically, like, if this is set to 1 hour, then it means all attestations created that are created will expire after 1 hour of its creation maximum. So you can impose some kind of limit on that one. Created by Caleb. Thank you, Caleb. So the network, the data location. Now, the data location can actually be separate. So I'll show you later what that means. Transaction ID, you can go to the block explorer if they're revocable, okay? And also the schema details, this is interesting. So this defines the data format that's in the attestations. Now, you don't have to follow these rules. You can, like, feel free to misuse this one, but the only downside is that, one, you'll be confusing people, like, how the hell can I decode your data? Because the point of having a schema is to explain to people how they can interpret your data, right? Instead of them having to go through like some kind of tool or your documentation, they can just see it here. It's very, very easy, right? And the second downside is that if your schema data doesn't describe your attestation data correctly, then we won't be able to decode it for you on the website, right? So that's another downside. So now we just clicked into an attestation. And you can see also like IDs and created at, expired at, everything else. So this one actually expires in a year. So that's quite interesting, right? Who's the attester, what the schema is. Reference attestation, so you can actually link attestations together. And revoked, no. Now, I don't know why that's all caps. I'll have to fix that bug. Or it should be false. So this is like an overview of SignScan. You can go to the front page and check out like some of the other ones it's loading. Some of the different schemas that we have, and a lot of these come from like our own events and our other products. So there's that. But in terms of code, I'm so sorry everyone for blinding you. But this is an example of a schema hook. So a schema hook really is just it's a smart contract, right? And it just has to conform to this interface because in the I'm sorry, it's tiny. Let me try. Okay, here we go. so in the sign protocol smart contract, we actually call the hook. We detect if the address is not 0, then we call the hook, and we call these different functions based on the scenario, right? So these two are receiving attestations. Now you can even like charge a fee as the I call it resolver here, but it's really the hook. And also if in the schema it says the attestations are able to be revoked, then you'll receive like a hook call when the revocation happens, right? And this is an example of a hook that we wrote, right? So it's like a whitelist manager. Basically, the point of this contract is so that it's to maintain a whitelist where only the whitelisted addresses can attest. But there are many more things that you can access, right? So if you look at the parameters here, you've got attester, schema ID, attestation ID, and then the sender will always be signed protocol. So you can call the signed protocol contract based on your schema ID, and then you can like pull the entire attestation object as well, right? So and we have like all of our interfaces public and nicely documented. Look at that, right? I'm proud because I usually don't document things. Yeah, but that's like a really quick overview. It's a little bit rushed, but because we don't have enough time. But again, we'll be at the booths, so we're just here to kind of get you started, and I'll hand it over to Jordan to talk about our front-end SDKs.
Yeah, so this is also, I think, pretty simple to get started. You would just need to import at ethsign /sp-sdk, like you would see here, into Yarn, into NPM, whatever you may use for your package manager. From there, you have access to all of our other functions that should make a lot of this super easy for you to create, whether it's a schema, a attestation, or even to retrieve all of the data from our indexing service. So for example here, I'm just showing you how to create an index service. And in this case, we are creating one for testnet. I fully expect that all of you will use testnets throughout this hackathon. And it's important that you use this testnet because we do separate our testnet index service from the mainnet index service. So if you create the wrong one and you try to query those specific IDs, you will not receive the data you're expecting. With that said, our client, when you go to create these different schemas or attestations, you'll need to specify the mode. So in this case, on-chain, this will give you access to all the different EVM chains. So in this case, we're using base Sepolia. But this could also be off-chain, and in that case, you'd be looking at using Arweave. Within each of those different classes, you have a bunch of different functions. So to start off, I think I'll just go ahead and discuss the indexing service because it's a bit shorter. You have access to query the schemas. The schema list one here will give you the option to supply an object. You can put in any information that you deem necessary. So this could be the attester. This could be like your, potentially even like a schema ID if you already know that. And there are other different things you can also query these based on. So definitely look at our documentation there for that access. And similarly, when you do queries for attestations, it's the same idea. So with this list function here, is basically you supplying the information that you know and expecting to receive a list back on these attestations. With the one that does not say list, so for query schema, query attestation, that takes in an ID. So pass in the ID that you would know ahead of time, and that will respond back with all the relative or relevant information. So if you are retrieving an attestation, it will also send back the relevant schema information as well. So that can help you with decoding, which we also supply a helper function for, which is decode on-chain data. Within that, you'll supply the schema's data field, which basically defines the different types that you'll have in your attestation. And you'll also supply the hex value that we store for just for saving space on our different contracts. Within the actual sign protocol client itself, you will be able to create schemas, get schemas, delegate. So when you potentially want to delegate schema or attestation creation on behalf of a user, you can also do that too. So potentially you might consider, as a backend, you want to create something on someone's behalf and still technically have them be the attester. They would need to sign to essentially approve this information, and then you could potentially pay gas fees for them or something along those lines. So in that case, you would need to sign it. You would pass in that signature along with all the attestation data that you'd have in the create schema or potentially create attestation functions. And the idea there is we don't want somebody to create an attestation on your behalf without you knowing about it. you need to approve that somebody has access to make an attestation for you, because otherwise it's a major security risk. And as I move down here, you can get the attestations, and then lastly, revoke. So same as when you create schemas or create attestations, you can also do a delegate revocation as well. You'd also just pass in that signature into the function, and you're good to go. Do note that revoke may revert if the schema does not support it. So in that time, the smart contract will check and make sure that you are able to revoke each of your attestations before actually proceeding with that action. With that said, please join us on Discord, on Telegram, whatever's easiest for you. These are just a couple of links we have. Feel free to also stop by our booth. We can give you more links. You guys can get in contact with us directly if you'd wish. And I believe that's it.
We made it on time.
So with that said, we can go ahead and turn this over to questions that you guys may have for us. If there's anything else, yes.
So if you want to do the on-chain or off-chain storage, is that using an Arweave testnet? How would that work?
Just for the recording, the Arweave testnet, you're asking?
Repeat the question.
Yes. So he's asking, when you're using Arweave, it was you're asking if it's based on an Arweave testnet or if it's on Arweave. Yeah, for the hackathon. Yeah, so for using off-chain on the hackathon, it is actually on Arweave's mainnet. We pay the fees. There is no fee for you. It'll be free for you to access. Arweave is cheap enough that we just sponsor the fees for you. So if you really want like the ultimate cost saving, obviously testnet you can probably find through ETHGlobal. You can find the different faucets. But for Arweave, it's paid for.
But there's you don't have the callback if you use that?
Correct. That is the trade-off with Arweave. With Arweave, you will not be able to set up a schema hook. That all the schema hooks are specifically referencing smart contracts on chain, and there is no way for us to call that from our backend to get that information processed.
Sorry, can you explain how the schema hook works?
Yeah, you bet.
Yeah, so the way that the schema hook works, and let me go back to the picture that no one can see. So basically, a schema hook is an external smart contract that's attached to a schema. By attached, I mean that the schema references when you first create the schema. So there will be a field that if you use our UI, it will ask you what's your like schema hook contract address. So it's a contract that you write yourself, right? And it has to conform to. Okay, how do I unclose? Technology. So the hook that you have to write has to conform to this interface. Right, so the contract that you write has to conform to this interface because these are the functions that the Sign Protocol smart contract will be calling, right? And we have an example here. Well, this one didn't. So we have like 3 different schema hook examples actually. Actually two. Sorry. So this is like a more complicated one. But basically, every time you make an attestation, okay, every time an attestation is made on the schema with a schema hook, the data will first go through the hook, run through the hook logic. Now the logic could be you can check for who the attester is. You can decode the attestation data to see like if some value is sufficient or whatever, whatever your conditions are. Or maybe you simply want to call another function in a different smart contract to notify them of something. That's all fine, right? But the point is like you have the power to like revert the attestation, the attest call in your hook contract. So it's a way for you to like, you can use it as a way for you to like gatekeep your schema or something. Like maybe only people authorized can attest because it's like whitelist. It's like a whitelisted system or something.
Take payments too.
Yeah. I didn't hear what you said.
Just to take payments. Yeah, I mean, the last thing I was just trying to say there is, you can also just take payments. I know we briefly mentioned that earlier, but if you wanted, potentially your use case here for these attestations, maybe you want to charge something to the users making these attestations. If they don't pay enough, you could revert. So some different, criteria there, but it really comes down to whatever you feel the need to do when somebody's trying to either make an attestation, so create one, or potentially revoke it. Those 2 times are when you'd be receiving calls to the schema hook, and do whatever you want with that information. You can revert if you just felt like it, flip a coin. But it just comes down to whatever logic you want to build. All right, thanks guys. That's our time. Please feel free to stop by our booth, ask us any questions you may have. We'll be here throughout the weekend. We're happy to help. Thanks. Thank you.
Testing. All right, awesome. Welcome, everybody. My name is Sawyer. Welcome to the Secret to Zero Gas Fees workshop. I'm here today representing the Scale Network. So I hope we have some hackers here. I see some faces I met last night, so let's kick things off. So again, my name is Sawyer. I run Scale's developer success team, and I'm also an active community developer. So super excited to be here. It's actually my second presentation at ETHSF, which is awesome. Great to be back. Just for a little bit of background on me, software engineering background, got into kind of the DevRel developer success kind of work a couple of years back with Scale. And since then, I've helped hundreds of developers build on blockchain across Scale, and overall just really love to support everybody building. So if you're around this weekend, come find me at the booth. I'll be here helping you guys hack. On to Scale. So for those of you that don't know, the Scale Network, it is built different. It is built different for mass adoption. How do we actually do this? We do this through a combination of high throughput, sustainability, and scalability. I know that's a lot of buzzwords, but throughout this presentation, I promise I'm going to work through all of those, okay? On to probably the most important thing, and the thing that most people, at least if you haven't heard of Scale yet, you'll know zero gas fees soon enough. Zero gas fees is something that if you haven't seen in the blockchain space before, that's okay. It's here, and it's been here, and it's big, okay? The reason for this is blockchain's really great, right? I think everybody can agree that it's pretty cool to see people take control of their data, of their assets, right? Do things in a way where they can be more flexible, right? Maybe a little bit more freedom. But we don't always want to do that, at least I don't ever want to do that, by sacrificing the user experience. And so the biggest thing that zero gas fees enables is an incredible user experience. On top of that, it also enables great business economics or unit economics, okay? Now, moving into Scale itself, because I know I haven't really touched on it, I've just thrown a bunch of buzzwords at you. Scale is 100% EVM compatible. So if you use Hard Hat, Solidity, right, Foundry, all your favorite tools, 100% compatible. This is obviously big because we don't want to force you to learn something new, just come build. We want you to be able to build what you want with what you want. On top of that, high throughput. High throughput is critical, and it's also one of the reasons why Scale's had such incredible growth over the last couple of years. Not only is it one of the top blockchains in the world, it's actually been called the top blockchain for gaming by CoinGecko, which is really exciting because I've worked with a lot of games, some really incredible ones, and they're really pushing the pace with how they use the chain to throw data at it like nothing you've ever seen. Now, on top of that, something really critical is building without limits, okay? I'm all about this. I've written a couple blog posts about it. I live and breathe this kind of thought process, which is when you're building a traditional application, right? So let's take blockchain out of it for a second. You've got a database, you've got a web app, you've got a mobile app, something like that. You are not limited by, oh, you can only send X amount of data. You've probably seen LLMs, you've seen big AI data applications. They're pushing terabytes of data back and forth throughout the cloud without any issues. So how come so many blockchains are restrained by 30 million gas units in a block? We are not. Over 268 million gas units in a single block allows you to put more on chain than you've ever been able to before. By the way, for comparison, that's about a 768 time increase than most of your popular chains. Let's step back to why zero gas fees. And before I do that, I should probably intro Scale a little bit. Otherwise, some people in the crowd are going to be a little bit mad at me. So we have this blockchain, right? Scale Network. But it's not just a single blockchain. It's also not a roll-up. Okay, so if any of you are L2 people, Scale is not a roll-up. It is not a layer 2. It is a network of blockchains, okay? And that's really critical to the scalability piece I mentioned at the beginning. So this network of blockchains, right, every single one is EVM compatible, has zero gas fees, super high throughput, hundreds of TPS per second. It's essentially a network of mini Ethereums, but cheaper, faster, and allowing you to build what you really want to build. Now looking at zero gas fees, because that's what this presentation is about, right? That's what our bounties are all about. So if you're hacking, make sure to check those out. Why zero gas fees? Again, User experience is critical. We want you to be able to build for real people, right? Not just bots and whatever else people are doing on their chains. We want real people using blockchain, and that's what you can build on scale. Additionally, a big thing is because there's no valued gas token, right? So we do have a gas token, it's called S-Fuel. I'll get to that in a second. But because there's no valuable gas token, you do not have to force your users to go to a centralized exchange or an on-ramp in order to start using your application. That is a huge area of friction. We see lots of people churn out trying to come into blockchain. We don't have to deal with that. Additionally, I'm not going to hate on it because it's really cool technology. Account abstraction, right? It's hot, everyone's using it, but why is everyone using it? Primarily, gas abstraction. Again, you don't need that on scale because we don't have gas fees. Additionally, no gas fees means greater scalability, right? I know, no pun intended, the name scale, but throttled throughput is a big problem, right? So one of the things we haven't seen in a while, because we've obviously seen, you know, we're in a bit of a down market from a usage perspective. We're seeing a lot of chains have much less users and throughput going on. And the reason that's important is because gas fees are a lot lower. And so with gas fees being a lot lower, throughput's not really a concern for a lot of these chains. But when everything kind of picks back up and you see a lot of these chains start to, you know, grow in usage, they start to get throttled. They start to kick people off, send them to their own L2s, things like that, right? We saw it a few years ago, and it wreaked havoc on a lot of ecosystems. And so that is one thing you do not have to worry about with scale. Lastly, again, is unit economics. So looking at a gas fee, right? Gas fees being variable, as chains start to get congested, things start to cost more, right? Because you're essentially trying to outbid someone else for that compute space. If everybody's gas fees are zero, you can basically have the best unit economics hands down, right? Because again, you're not competing for every single little bit of block space. You're simply outright buying this block space. I'll get to that more in a little bit as well. Deep diving into S-Fuel. So especially for the hackers here, S-Fuel is really key. S-Fuel or Scale Fuel, right, works just like Ether on Ethereum mainnet or, you know, other gas tokens and other networks. The big differentiator is it has no monetary value, right? So again, it cannot be purchased. It cannot be, you know, swapped for. It's not on decentralized exchanges, anything like that. It has to be given to you. And that is by design because Scale at kind of its base layer was designed to be an app chain network. And so these chains are designed to be encapsulated, right, kind of within their own ecosystem if they want to, or our hub chains allow these ecosystems to grow, let other people in, and kind of let that S-Fuel trickle down. That being said, if we're zero gas fees, why do we have a gas token? As you can probably see, it's for security, right? We do recognize that, you know, networks that have very cheap gas tokens, we've seen them get DOSed in the past. It's not pretty, things go down, everybody gets mad. Because S-Fuel is a protected resource, it allows us to, well, not us, it allows developers to meter the users, right, and meter other applications to protect the network and its resources. Again, S-Fuel, right, if we have to give it to people, we have to talk about distribution. The reason I wanted to add this in specifically is because for the hackers here, this is something that if you add into your dApp this weekend, if you're building on Scale, going for the bounties, this will make your dApp way better. It's something that we work with every single project building on Scale to help them add, and it's critical to having a great onboarding experience. So, Scale chains, they don't have any gas fees. End users need this S-Fuel to transact. So what do? We give it to them, right? But you'll notice the very last word on the slide is invisibly, right? Zero gas fees, very fast, great user experience. How do we do that? We create invisible experiences. And so a big thing is if I go to a dApp on some chain and they say, hey, you need gas tokens. They throw a modal in my face. They say, hey, put in a credit card, KYC, do all this stuff. You don't have to do that on Scale, right? In fact, you don't even know there's gas. When you go to these dApps, you connect your wallet, or maybe you log in with an email, or maybe they spin up a key for you, whatever it is, right? There's no restrictions here. So decentralized network. They just give you a little bit of S-Fuel. Just like that, you're off to the races. Moving on to a bit more about how the network operates based on this, because the question that we always get is, if there's zero gas fees, how do the validators get paid? How does Scale make money, right? Before we can kind of look at that, we have to recognize that because there's zero gas fees, right? Validators are not getting paid transaction by transaction, block by block. Validators are getting paid to essentially work together and make the chain. And that's one of the reasons why we don't have forking, right? Things are incredibly fast and things are incredibly secure. Additionally, as long as, just a kind of a call out to the broader scale architecture, as long as less than 1/3 of the nodes are not Byzantine, AKA not malicious, not unsynced, not down, the chain just goes, right? So again, there's no round robin consensus, nothing crazy there. The chain just builds. Looking at the actual incentives, because these validators are all just working together, they have to get paid, right? Because the way a decentralized network operates is someone has to be incentivized to run it and everyone else pays to use it. But as we've recognized and built out, it's not sustainable for us to do this transaction by transaction, block by block, right? Things are too variable. It doesn't work for real businesses. That is how most networks work, whether they're L1s, alt L1s, L2s, L3s, whatever it is. They have gas fees, and if they are a proof of stake network, they may have some form of inflation that their validators get. Scale validators do get inflation. There is a token called SKL. It lives on the Ethereum mainnet. It's delegated by people. The validators take that token, they stake it into the network, they use it to collateralize their nodes. It's part of why the network is so secure. They get bounties every month. They take a small fee of that. But we recognize that with pretty much all proof of stake tokens, the inflation generally goes down over time, right? Because there's less and less tokens that get created, the supply starts to shrink. And so we had to make sure that this was something that would last forever. And so in order to do that, what we have is kind of akin to a cloud as a service, right? Your AWSs, your Google Clouds, Azures of the world. There is what we call scale chain payments or scale chain pricing. This pricing is something where chain owners, right? So again, Scale's a multi-chain network. There's many chains. The chain owners pay into the network every month directly to the validators. And so this is, again, very different, I know, than many other chains. But the key is that it creates sustainability and stability, right? As a developer, what happens if you have 1 million users tomorrow? You have 5 today and you got 1 million tomorrow. Your chain is just going to break, right? Gas fees are going to go through the roof. With Scale, they just stay at 0 the entire time. The price is set through governance, through the Scale DAO. The fees themselves are paid in the SKL token. They're actually paid on the Europa hub, which is one of the Scale chains. They're not paid on Ethereum mainnet. That was a decision made by the community to help save chain owners gas fees and help validators not have to pay those gas fees when they were claiming. And then lastly, again, just kind of calling out to the sustainability, validators all get paid equally out of this. So it does not matter whether you're running 1 node, 5 nodes, or someone in the future could be running 1,000 nodes, right? As the network continues to grow, every validator node gets paid equally, okay? And so again, that's very critical because what this means is every validator node can run multiple scale chains. And so it doesn't matter whether you're running 1 chain or 5 chains, you're making the same amount of money. And this is key because in order to allow the validator set to continue to grow, we always need to have excess nodes in the network to allow new chains to be created. And so this, again, creates that sustainability to let the network continue to grow as needed without running into any sort of supply issues. Jumping away from more of the technical stuff and looking, again, at why zero gas fees is so important, user experience. So this is actually a demo, which I'm hoping it'll let me play here. Perfect. So this is one of our earliest games that went live on Scale called Voxelverse. Incredible game devs, great pedigree. But what you'll notice is as this guy walks around, he's picking up rocks, he's picking up wood, he's picking up meat. And you'll notice that on the left side, there's transactions firing. And they just happen. Again, no MetaMask popping up, no extra clicks, no gas fees in your face. It just works. And so again, this is just a great showcase of how the Scale network design and architecture lets people build real experiences, especially for gaming, where if anybody's a gamer here, you're probably aware of some Web3 games maybe not being so great. This is a way for Web3 games to build great games first and then add blockchain for the benefits of blockchain afterwards, right? They don't have to sacrifice one for the other. Sorry about that. There we go. moving forward and kind of double clicking back into unit economics, because this is really critical for kind of long-term people trying to build long-term in the space, right? So the idea for, I think, most companies or most people trying to build a company is you start and you want to grow. You want to grow big, right? So today, most developers that are building on Scale, they start on one of our Scale hubs. We have 4 of them. We have a gaming hub called Nebula, we have a DeFi and liquidity hub called Europa, we have an AI hub called Titan, and we have a Calypso hub, which is a bit of our social, kind of broader innovation hub. However, as you grow, right, let's say you start out doing a few hundred transactions per day, you move up into the thousands, next thing you know, you're doing millions. You're going to be eligible for your own Scale chain, right? Because you need all that compute now. When that happens, you're now thinking, oh, wait, I have more expenses, right? But you also have way cheaper transactions, right? If you look at these unit economics, this is kind of how the economics of the network are designed. Scale chains cost a flat fee, okay? Right now, the network fee is set at $3,600 per month paid in SKL tokens. However, this number that you're looking at is actually based off of $10,000 a month, based on the fact that the community believes that over time, the pricing will increase because the value of a chain is very high. And so this is actually more expensive than what it costs today. But what you'll notice is this is a fraction of a fraction of a fraction of a penny, right? We still see L1s and L2s out there today that have, penny, 10 cent, 50 cent, even sometimes, dollar plus gas fees. And again, it's just not realistic to onboard the next, let's not even call it a million, the next 100,000 people into Web3. It's just not going to happen, right, with those gas fees. And so this is just some really good proof for how great the unit economics are that allow you to build a real business on top of the Scale network. Additionally, just a call out to some of our other bounties this week. We are putting the majority of it behind zero gas fees, but we have a bunch of other features, such as our native IMA bridge, our on-chain RNG, our on-chain Oracle system, and our file storage. All of those are part of our other set of bounties. It's important to note that these are all included in that price. So you're not paying extra for Oracle. You're not paying extra for RNG. You're not paying extra for file storage. This stuff is just baked in. So again, I know it's a lot of information coming at you very quick. The Scale network is generally more complex than other chains, but it is incredibly powerful. So just keep that in mind as you're planning to build this weekend. This is my last slide, so I'm going to pause here for a second because I'm a bit ahead of where I thought I would be. And so I just want to kind of take a step back and kind of recap Scale network again, because like I said, I know I went pretty deep into gas fees first, but I wanted to make sure I had enough time to talk about the benefits before I went into deep technical information. So kind of taking a step back real quick, and then I'll open it up for questions. So again, the Scale network is multi-chain, okay? It is not one chain, it is not an L2, it is not a rollup, it is a network of many chains. Layer 1 chains, very powerful chains. I always like to call them mini Ethereums just because, I knew Ethereum before everything else, and I think it's a great way to kind of conceptualize what the network looks like. Looking at the Scale network as a whole, obviously like we've talked about here, right? Zero gas fees is kind of the bread and butter, right? It's the thing that everybody knows it for, but it's incredibly fast, it's incredibly powerful, and it's incredibly versatile. You can build almost anything on this that you can build on any other blockchain, plus you can build true Web 2 experiences side by side. Looking outside of the unit economics, specifically at the validators, it's also really important to call out that Scale is very decentralized. A lot of people, right, in the space right now, there's a lot of back and forth around what should be decentralized, what shouldn't. That's an area that Scale has never taken a step back on and said, hey, it's okay to be centralized. We want to be decentralized because we believe that if you're building on blockchain, use blockchain for what it should be. And so all of the validators are third-party organizations. They're not run by Scale Labs. They're not run by the Node Foundation, often referred to as the Scale Foundation. They're run by top-tier validator organizations, Figment, Blockdaemon, Chorus One, as well as a number of smaller ones that we love to work with, like O1 Node, Easy to Stake, et cetera, et cetera. It's also really important to look at the time that Scale's been around. Scale's been around for over 4 years now. I think we just had a birthday a couple weeks ago, which is really exciting. And that's on mainnet. In that time, we've had a number of releases. Our V3 was actually just a few months ago. We had some incredible performance improvements. And then looking back a couple years ago, our V2 opened up chain-to-chain communication. So again, there's a lot of features, not enough time to talk about all of them. But if you want to come ask me about them later, I'm happy to talk to you about them. But lastly, I think the most important thing when it comes to scale is there's always more information. We have very detailed docs. We have an incredible team. We have Jack here, CEO of Scale Labs. We have Connor, our head of sales and strategy at Scale Labs. We have Ben, our head of partner marketing. And then Zara is one of our amazing marketing individuals as well. So we have an incredible team here to support everybody this weekend. And so like I said, I know there's probably a lot of unanswered information, and I will get to it probably just individually because there's just never enough time. But that is what I wanted to get through. So thanks everyone for listening to me ramble for 20 minutes. Questions? Thank you.
What happens if a chain stops paying for the gas fee? Let's say you pay $10,000 monthly and you don't pay, and I'm one of the users and I have like $10,000 of assets,
Mhm.
maybe in DeFi.
Yeah.
And suddenly the company stops paying for the gas fees and I lose all my money.
It's a fantastic question. So what happens is, as per the governance proposal, which all this is public, right? This is all 100% online. You can go to the forum, you can go to the Scale DAO on Snapshot, you can see it all. The way it works is if a chain stops paying, they have a 3-month period where they essentially have the ability to pay down their debt, right? So let's say they stop paying today, come, I believe it's January 1, they need to pay back all that debt. Otherwise, at that point, their chain comes up for, is basically eligible for deletion by the network. In that case, what happens is all of the assets on the chain would be migrated over to one of our hub chains. And so that can happen in one of two ways. Either one, a team of developers can basically take a snapshot and they can airdrop essentially all the tokens back over. Or what would more realistically happen is our IMA, so our interchain messaging agent is our native bridge. It is actually baked into Ethereum. So we have a lot of pieces of our network that are actually baked into Ethereum for extra security. And so our primary bridge is actually a lock and mint bridge where people deposit assets on Ethereum, they get minted on a Scale chain. And so what happens then is there's actually functionality where when a chain is being deleted, all of those assets get pulled out of the chain back to Ethereum, back to the chain owner, and then that chain owner can again then airdrop them back to the user. So the big thing here is, again, this is a decentralized network, and so there's not one single person in control of all of the chains. It's really a chain by chain basis thing. But the big thing that we recognize is if something like that did happen, you know, there's a lot of people that would obviously want their assets. Then it's basically developers come, they say, hey, how can we transition all of this over to a place that's going to continue to exist, which realistically is going to be those hubs long term. Great question. Yeah.
So I understand, like, whenever you deploy an app, like, when does the app, so as a developer, I have to give the gas as bill to my users. So when does my app get the as bill?
Absolutely. Also, I apologize, I forgot to repeat your question. I'm supposed to repeat the questions first. Question was, when a app is going live on Scale, when do they get access to S-Fuel on mainnet? So I'm actually going to start on testnet just because it's very important to the process. We always recommend people deploy on testnet first, right? Especially because Scale is very different. Make sure you kind of hit everything, make sure it all works. Once you're actually going to mainnet, what then happens is you'll either be introduced to the owner of a hub chain, if you're going on a hub chain, or we'll work with you directly, the DS team will work with you to get you the assets you need, aka the S-Fuel. You'll get a small deposit of S-Fuel during that kind of go live process. You'll then be able to deploy apps. You'll be able to get whitelisted on mainnet, have access to deploy, etc. So all of that happens when you're actually going live. That way there's no wasted resources and no, we'll call them leaks in the network, meaning if everyone just got a bunch of S-Fuel, it obviously wouldn't be a scarce resource, wouldn't be very secure. And so the idea is that only people going to deploy actively on mainnet are eligible to attain these resources. And then you would then distribute that out to your users as they come. And then usually the natural follow-up to that question is, what happens if I run out of S-Fuel? You simply request more from the hub owner. There are public faucets on all these chains that distribute very small amounts directly to users, but we do find that a lot of applications prefer to do more manual distribution just for speed purposes. It allows them to create better experiences. And again, because it's a decentralized network, you're more than welcome to, right? There's many ways to do the same thing, and it's a great option for people trying to create invisible experiences.
So on testnet,
Yes. Yes. Correct. Testnet is 100% permissionless. So this QR code on the screen actually will take you right to the docs. It'll take you, we actually have one of the only documentation sets where you can get gas and ERC20 tokens right in the documentation. So go on, pick a chain. There's 4 of them. Our Europa, Nebula, Calypso, and Titan hubs. You go on, you select your chain. It doesn't really matter if you're hacking this weekend. They're all pretty much the same from a technical level. Minor optic differences. You can get gas right in the docs. If you don't want to go there, sfuelstation.com is the community faucet. It has all the testnet chains as well. But if you ever run into an issue, you're having problems getting sfuel, just come find me or join our Discord, ping the developer success team. Again, we're here to help. Everyone should have access to the resources they need. But fantastic question. Anything else? Yes. Yes. It's a complicated question. It's a loaded question because there's a lot of factors. Sorry. Is Scale the world's fastest blockchain? Thank you. It's a complicated question because there's a lot of factors that come in, but the answer is yes. And the reason is for a couple of reasons. One, throughput is obviously key, right? But everyone's fast now. Everyone can do high throughput, or at least so they claim. Finality is what is relevant here. Because at the end of the day, you can hammer a blockchain with as many transactions as you want, but if things aren't settling right away, then you're basically running in an optimistic world, right? But a lot of these chains have, multi-minute or even multi-day periods for settlement, especially when you start to get down to the L3 level. And so the way that speed, like I said, is kind of looked at, it's generally looked at TPS is like the primary metric, but the answer is Scale is not only the fastest in terms of TPS, at least according to the Dartmouth report, which if anybody's interested, we can send anybody after, but more importantly, in my opinion, is finality. Because if you are not final fast, then you're just basically run centralized, right? There's no reason to be on blockchain at that point because you don't care. And so hope that answers the question. Like I said, I know I have a bit of a different opinion on it, but we are both fast and finality is insanely quick. It's about 1.2 seconds on average on a Scale chain right now, and it's only getting faster. Our engineering team is making incredible advancements month over month, quarter over quarter, and things just keep getting better and better. Also, fun fact for everybody, Scale chains can't fork. So I know that's still something that a lot of chains have to deal with. Because of how unified validation operates, where all the validators work together, basically if there is a fork, that means there's a state mismatch, and those validators have to resync and get themselves back. And so it also means that when a transaction has one block confirmation, aka it's added to the chain, it's there, it's done. And so again, speed is very important, but I think there's multiple ways to look at speed. So hopefully that answers the question. It could be either or. The current Scale hubs are all DAO operated or just kind of like loose groups of people. Some of them are at different stages. So our Nebula hub is run by primarily by a team called Prospectors, but they're in the process of decentralizing out into a DAO. The Calypso hub is operated by a group of about 7 different people, very loosely. Again, they're also looking at kind of moving more into a DAO format. I'd say our Europa hub is probably farthest along toward being a DAO. They have some public pieces that they've looked at performing and pushing toward for a while. But at the end of the day, Scale chains are rentable resources. So any group of people or entity or DAO can come and say, hey, I want a Scale chain. I'm willing to pay for it. And they can operate that Scale chain. DAO, business, corporation, group of people, partnership, individual. If it's on the chain that you are operating, you have the ability to choose who deploys. Once someone is deployed and they're active, there is no current way to censor a project because again, it is a decentralized, permissionless network. But you do have the ability to choose who can deploy. Any other questions? These are great. Keep them coming. Yeah, so it's less of an issue now on Ethereum specifically since the transition to proof of stake. I believe the metric that I saw last was 99% of blocks are good. There's no forks. But basically what happens is when you have a decentralized network, there's a bunch of different, we'll call them people here, or entities, trying to build a chain, right? A chain of blocks. But the problem is no one can trust each other. right? That's where everyone's putting up a bunch of collateral and they're loosely sending transactions, broadcasting, grabbing stuff out of a mempool if there is a mempool, et cetera, et cetera. And what happens is when there's a disagreement, a new validator is selected who builds the biggest chain in a proof of work chain. Basically there's a hard fork every time, or a soft fork technically, right? So that was back when, it's very common with Bitcoin still, very common with Ethereum back before the transition to proof of stake, because again, whoever builds the longest chain, you can go back and basically change things. And so that's why if you ever did we'll call it, it's not as common anymore, but if you look 5-6 years ago, back when you used to deposit to a centralized exchange, they tell you wait 100 block confirmations because they were waiting to make sure there was no forking in the chain. Because scale chains work together, or at least the validators do, meaning they're all building together and they're just working through block proposals as quickly as possible, it solves the problem of the fact that the chain cannot fork functionally because all of the validators are on the same page. This is done through a combination of threshold encryption and BLS signatures, where essentially every validator who's running a node, when they get a transaction that comes in, they sign that transaction, they broadcast that transaction. At the same time, people are giving them transactions. Then they get to the blocks. They're building blocks. Once they believe that they have all the transactions, they then sign the block and say, hey, this is the winning one. They then broadcast that. Well, they're also getting broadcasted too. Then lastly, what happens is the winning block proposal that gets 2/3 of the signatures, aka the supermajority, gets actually selected and posted to the chain. And so because this is scale specific, by the way, because this is how scale operates, it's physically impossible for the chain to fork. Because if it forked, it means that the validators are on different pages and people are going Byzantine and they're malicious. And so at that point, the chain just pauses. That's also fun fact. Scale chains, they don't go down, they just pause. As long as there's validators running, they just basically keep trying to build the chain. And as soon as 2/3 of the validator nodes, aka 11 out of 16 in our current chain sizes, are back and running and healthy, the chain just picks up where it left off and keeps going. Yeah, I know I'm a bit over time. I don't know if I need to vacate the room, but if there's more questions, I'm happy to field them until they kick me out. Also, for anybody watching on the live stream, that was a question about how does scale chain prevent from forking. If no other questions and everybody's leaving, 20,000 up for bounties, build zero gas fees, build with the best use of zero gas fees or our scale native integrations and features. Again, link to the docs. I'll be around all weekend. Yeah, come by the booth. Thank you, everybody.